Welcome back. The last category of fuels that we will explore in context of freight sector is called e-fuels or synthetic fuels. The opinion about the potential of e-fuels is divided among professionals and researchers. Some that are more bold than others state that e-fuels will be available at the pump at low price by 2030. While the future for the e-fuels, also called power to liquids, power to gas, e-gas, or electrofuels, is yet to be determined, freight sector is devoting substantial amount of energy to study this topic. So what are e-fuels and what challenges do they face in current market? To produce e-fuels, electricity, preferably renewable, is used. Generalized diagram of the production process is presented on the current slide. Feel free to pause and take a closer look. While e-fuels can be very low carbon if made from new, additional renewable electricity, it is difficult to keep them at the low cost at the same time. Just like in the case of hydrogen, one of the biggest challenges the sector is facing is inefficiency. The e-fuel production process is not very efficient as it converts at best half of the energy in the electricity into liquid or gas fuels. Although the costs of wind and solar energy are coming down over time, e-fuel production is not predicted to be an inexpensive process, at least initially. It is definitely too early to speculate the exact prices of e-fuels, but to give you an approximate range, some predictions state that it will cost a few euros per liter in 2030. In transportation, and particularly the freight sector, the comparison of efficiency between direct charging, hydrogen, and power to liquid is not in favor of e-fuels due to high energy losses. When evaluating the efficiency, there are a few steps to take. First is called well to tank, and it is fuel production efficiency. In case of direct electrification, this number is around 94%, whereas for hydrogen, it is around 68%. The next step is called tank to wheel, and it is the energy output from the wheels and the energy content of the fuel in the tank, and there can also be substantial energy losses along this pathway. In case of direct electrification, the efficiency goes down from 94% to 77%, while the efficiency of hydrogen drops from 68% to 33%. The losses for power to liquid and power to methane are even more substantial. Please feel free to pause to take a closer look at this image. Looking into the future, it is predicted that every fuel pathway will become more efficient by 2050, although it is argued that direct electrification will remain to be most efficient in the upcoming years. Please note that there are still losses in direct electrification. They're not as big as they are in other types of fuels like hydrogen or e-fuels. This is a simplified version of the tables we have just studied, where you can see the efficiency differences more clearly. In essence, just like passenger car sector, freight is also exploring alternative ways of power and to some extent faces similar challenges. Different electric drive technologies are suitable for different heavy-duty vehicle segments, but massive infrastructure investments would be needed in most cases. In addition to the variety of factors, the type of technology will also depend on the range and the environment needed, for example, highway versus more urban. In the end, we shall not undervalue the source of the energy. As Professor Tavasi, an expert in freight, says, the other challenge is to get energy from clean sources. If electricity is made from coal, the environmental benefits will not be as significant as expected. Up until now, it is only a few countries, like Norway, that uses hydroelectric power as the main source of electricity production, produce a sufficient amount of clean energy to sustain low carbon economy. Stepping up clean energy production will be critical in decarbonizing the freight sector. The trends in the world for hydroelectricity production vary by region. The nearly 40 countries who belong to the Organization for Economic Cooperation and Development have been leading the way. Over the last couple decades, China has also increased the hydroelectric production. Advances in battery packs, electricity production, and other electrical components will indeed enable shorter distance urban commercial vans to become plug-in electric, similar to cars. Battery electric vehicles with overhead catenary or in-road charging could allow electric zero-emission transport of goods on and around heavily traveled freight corridors. All these technologies have their unique barriers and required sustained and extensive infrastructure investments by government and industry and research. For example, overhead transmission, in-road charging, hydrogen refueling station. Hydrogen fuel cell technology have potential for high-distance travel. However, environment-wise, fully electric systems like battery EVs, together with catenary for long-range support, seem to make the best economic case at the moment, as the costs are a fraction of the infrastructure cost for hydrogen. Please feel free to pause here and explore this table to find out some details on the potential and barriers of technologies such as electric plug-in, electric catenary or in-road charging, and hydrogen fuel cell trucks. The most potential for plug-in EVs is found in urban areas for light deliveries and medium-duty regional delivery trucks. For heavy-duty and longer-distance deliveries, technologies like catenary on in-road charging or hydrogen cell fuel are found to be the most promising. Although in this video we discussed different fuel sources and related technologies as means to mitigate climate change, researchers are also working on improving operational side in context of route and delivery optimization or improving e-commerce distribution in urban cores. Alternative fuel types are just as important as the optimization of routing and distribution mechanism. Lastly, as Professor Tavasi explains, there appears to be no silver bullet for all situations, and different solutions may very well appear alongside each other in the future, catering for specific segments of the market.